Aircela machines produce motor-grade methanol from electrolytic synthesis of CO2. In an era marked by the urgent need for sustainable energy solutions, Aircela machines have emerged as a symbol of innovation by taking a direct swing at one of humanity's most pressing challenges: excess atmospheric CO2. By converting this greenhouse gas into fossil-free, motor-grade fuel, these systems not only address climate change, but also offer a pathway to power engines with a renewable, environmentally benign energy source. The process harnesses cutting-edge electrochemical techniques, repurposing waste carbon into a resource that fuels our vehicles and rejuvenates the energy landscape. The Aircela technology lies the process of electrolytic synthesis, a method that marries the principles of electrochemistry with advanced catalysis. The process begins by capturing ambient or industrial CO2, which is then fed into an electrochemical cell. In parallel, water is split into its elemental hydrogen and oxygen through electrolysis, powered by renewable electricity such as solar or wind. The liberated hydrogen acts as a reducing agent, reacting with CO2 in the presence of specially engineered catalysts. The efficiency of methanol production from alkaline-based electrolysis of CO2 varies depending on the electrolyzer design, catalyst efficiency, and operational conditions. Based on available research, methanol production can yield approximately 354 gallons of methanol per megawatt of input energy. This reaction typically marks the initial production of methanol, a useful chemical intermediate. The journey from methanol to fully refined motor-grade fuel involves further catalytic processing steps such as dehydration, oligomerization, and isomerization, reconfiguring the molecular structure into a fuel that meets the rigorous demands of modern engines. This integrated pathway demonstrates how leveraging renewable energy and electrolysis can convert waste CO2 into an energy-dense, high-performance fuel without relying on fossil resources. The term motor-grade fuel implies a refined hydrocarbon that is not only high in energy density, but also compatible with the stringent standards of modern internal combustion engines. Aircela machines achieve this by channeling the intermediate products from electrolytic synthesis into an advanced refining stage. Here, chemical reactions are precisely controlled to craft a fuel with optimal properties, such as appropriate volatility, combustion efficiency, and controlled emissions. Unlike conventional fossil fuels, the end product is completely free from contaminants that are typically present in petroleum-based feedstocks. This means that upon combustion, the fuel releases considerably lower net CO2, essentially closing the carbon loop, because the CO2 released was originally captured from the atmosphere. One of the most profound advantages of this technology is its dual role in both mitigating climate change and transforming energy economics. By continuously removing CO2 from the atmosphere, Aircela machines help offset emissions from industrial and vehicular sources. Coupled with renewable energy, the entire process remains carbon neutral. Moreover, the production of motor-grade fuel through these advanced techniques may pave the way for a new market segment, shifting our dependence from fossil-based energy systems toward a sustainable, circular carbon economy. The commercial viability of such a system is enhanced by its modular nature, allowing for decentralized deployment, from remote installations near renewable energy farms to integration within urban industrial hubs. These features promise scalability while reducing logistical inefficiencies that have traditionally hampered carbon capture systems. Aircela machines represent more than just an engineering marvel, they symbolize a paradigm shift in our approach to environmental stewardship and energy production. By turning captured CO2, a symbol of industrial byproduct and environmental challenge, into motor-grade fuel, these systems invite us to reconceptualize waste and resource. They ask us to question, can every molecule of carbon be an asset rather than a liability?